Equations with exponents. So let's look at the following problems. The first problem we have 4 to the power of x is equal 16. So the first step is to make the bases to be the same on one side of the equation and the other. So now we know we can write 16 as what? As 4 to the power of 2. But if you don't know how to do that, you can always use your calculator. For example, if you type 4 equal shift fact, you're going to write this 4 as a base of a prime number. So that's going to be the same thing as 2 to the power of 2x. And therefore now 16 as a base of 2. Remember, you just put your calculator and say 16 equal sign, and then you say shift fact. And that's going to give you 2 to the power of 4. So now when you have the same basis, you just drop the base and equate the exponent. So that's going to be 2x is equal to 4. And then you can divide both sides by 2. So the value of x is going to be 2. So this will be the same thing if, for example, you knew how to make the base of 16 to be 4. So you're just going to say you have 4 to the power of x is equal 16. So 16 can be written as what? As 4 to the power of 2. So therefore, when you have the same basis, you drop the bases and you equate the exponents. So the answer that you get is going to be the same answers. So this method here, the first one, is just that it's easy to do it because you just type whatever that you have in your calculator, and then it can give you as a base of a prime number, and therefore you'll be able to solve. So let's move on and look at the second example. On the second example, we have 3 to the power of 2 into x minus 1 equal 81. Okay, so the first thing we can just do what? Change this thing to the base of a prime number. But now we can also see here, we can just simplify out in the meantime. So we'll say now, okay, this 2 will multiply with x, and then 2 will multiply with negative 1. So we're just going to have 3 to the power of 2x minus 2, because now this 2 is going to multiply with the 1. And therefore on this side, to change this as a base of what? Of a prime number, you're just going to type on your calculator 81, and then you say equals to, then you say shift fact, and that's going to give you 3 to the power of 4. So now if you have the same basis, remember you drop the basis and you equate the exponent. So now you're just going to have this on the side, 2x minus 2, and then is equals to what? Is equals to 4. So you just equate the exponents. So after you equate the exponent, you just normally solve for x. So how do you solve for x here? You're just going to transpose the 2 to the other side. So this is going to be 2x, and then it's equals to 4. When 2 moves to the other side, it's going to be positive 2. Therefore, you have 2x is equals to 4 plus 2 is going to be 6. And then you can divide both sides by 2. So the value of x is just going to be 3. So that is how you can solve the second problem. So now if you look at the third problem, on the third problem, we are having what? 2 multiplied by 3 to the power of x is equal 162. Okay, so remember we just want to make a number that has only one base on one side of the equation. So this means now on this side here, we can just cancel this 2 here. How can we cancel the 2? We can cancel the 2 by dividing, because we have multiplication. So we divide both sides by 2. So this will simplify to be 3 to the power of x, and then you say now 162 divided by 2, and that's going to give you 81. And then we know now we can write 81 as a base of 3. We just use our calculator. We say 81 equals to, and then we say shift fact, and that's going to give us 3 to the power of 4. Therefore, if you have the same basis, you equate the exponent. So the x is just going to be equal 4. So that is how you do it. So if we look at the last problem, on the last problem we have 9 to the power of x minus 2 multiplied by 27 to the power of x is equal 3. So the first thing is just to change the basis to the prime numbers. So 9 can be written as what? You use your calculator, remember. 9 equals to shift fact, and then it will give you the answers. So now 9 can be written as 3 to the power of 2, and then you raise to the power of x minus 2. And therefore also 27 can also be written as a base of a prime number. So 27 equal sign, shift fact, and that's going to give us 3 to the power of 3, and then we have to the power of x. And this is equated to 3. So now we just have to simplify, remove the brackets. But now if you remove the brackets, remember this is going to multiply with that will multiply with that. So the exponent multiplies if you have the brackets. So this will simplify to be 3. 2 multiplied by x, that's going to be 2x. 2 multiplied by -2, that's going to be -4. And then you still have what? 3 multiplied by x there. So that's going to be 3 to the power of 3x is equal 3. So now we know if we multiply the same base, we add the exponents. Remember, the reason why we are adding here is because we just want one base. We don't want two bases like this. We want to have one base so that we can drop the exponents. So now we're just going to say, okay, we keep the base the same and then we add the exponent. So this is going to be what? 2x plus 3x. That's going to give us 5x. And then we still have that minus 4 there. And then this is equals to 3. But now remember, 3 is to the power of 1. So now if we just have a single base on one side of the equation and the other, therefore we can then do what? We can say now, okay, these bases will cancel out, and therefore we have 5x minus 4 being equals to 1. So when we solve for x here, we just move the 4 to the other side. So this is going to be 5x equals to 1 plus 4. So because we had 1 here, when we move 4, it's going to be a positive 4. And then this is just going to be equivalent to 5x equals to 5. And then if you divide both sides by 5, therefore the value of x is just going to be 1. So that is how you solve everything. Thank you very much.